Hello, mathematician. Today we're going to be taking a look at the distributive property. So some things that you want to make sure that you know how to do ahead of time as far as prior knowledge would be being able to multiply two terms or two factors like 2x times x and knowing that that would equal 2x squared. If you know how to do that, then you're probably ready to take a look at what we're doing today. So that's using the distributive property to expand algebraic expressions. And by the end of the video, you'll know how to solve problems like this one down here. So when there's one factor out front multiplied by, in this case, a trinomial, because it has three terms in there. So we're going to start by taking a look at example 1. And I'm going to use a little bit of color coding just because that can be helpful to know which terms we're talking about. So when we see the parentheses, we know that we need to multiply the 3x by both terms that are inside parentheses. So 3x times 2x, well, we do the 3 times 2 to get 6. And then the x times x, which gives us x squared. So that's the first part. And then we also have to distribute the 3x times the negative 5. So it's a positive times a negative, so it will be negative. 3 times negative 5 is negative 15. And then the x will just be right there at the end. So what we just did here is we multiplied those two parts. And it's also possible that they might ask you to take something like we got here for our final answer and factor it to get it back the other direction. So the direction we just went was multiplying. We'll take a look at factoring in another video. For some of you, that works out fine and that makes good sense. But if it doesn't, there's another way that I found a lot of students like laying out their answer. So instead of just kind of doing arcs, you could put the term that was in front off to the left side of a box, and then we'll put the 2x and the negative 5 on top of that box. And then we're just multiplying what's outside to fill in the inside. So again, 3 times 2 is 6, x times x is x squared. And then 3 times negative 5 is negative 15. And then there's also that x there. So then our final answer is right there in the box, 6x squared minus 15x. That's the same thing that we got doing it the other way. So you can take your pick, doesn't really matter which way. So let's take a look. What if we have a problem that has 3 terms there inside of parentheses? So it's really the same process. We still have to distribute that front, in this case, negative 2x. And this time we just have to distribute to each of those terms inside the parentheses. So negative 2x times x squared. So that's just going to be negative 2. And then x, that's really an x to the first. X to the first times x squared would be x cubed. And then next, we have negative 2x times negative 3x. It's best to think of it as a negative here, because then when we have a negative times a negative, we get positive 6. And then x times x is x squared. And then when we look at this last term here, so negative 2x times positive 4, and negative times positive is a negative. So we're going to end up with negative 8x. And that's our final answer for that one. Again, if keeping all that straight and keeping it laid out and organized is tough for you, you could always use the little box method again. So we'll take a look at that for this one, what that would look like. So here we would have the negative 2x out to the side here. And then up top, we're going to have the x squared, the negative 3x, and then the positive 4. And then when we're filling in the box, same thing. So we have negative 2x times x squared, which is negative 2x cubed. Negative 2x times negative 3x gives me a positive 6x squared. And then negative 2x times positive 4 is negative 8x. And as you can see, we get the same answer that we did before. It's just a little bit different way of organizing it. And for some students, they just find that the structure of the boxes is helpful for them to keep their answer organized. So after watching this video, you should know how to solve ones like this one down here. So why don't you, on your own time now, go ahead and give it a try. The answer's there. You can check and just make sure that you understand the process of how to make that work.